Welcome back. All right, so we're going to do a few more multiple transformations. Our first one, cube root. So let's graph our parent function. So there we go, 0, 0, 1, 1, and 2, 3, 4, 5, 6, 7, 8, 2, negative 1, 1, and then 2, 3, 4, 5, 6, 7, 8. All right, so negative 8, negative 2. There is our graph. And that one is y equals the cube root of x. All right, so we have a number in front. We have a coefficient in front. And it's negative. Right? So our parent function, of course, was the cube root of x. That's been stretched by a factor of 3. So all the y values are 3 times as much. And it's going to be reflected across it's in front of the radical, it's the x-axis. All right, so we're going to do 3 graphs on this one. The parent function is done, our dilation reflection, and then our translation. All right, so easiest way to think of this is just multiply all of your y values by negative 3. All right? I like to usually start at the center, because guess what? He won't change. He's going to stay just the same. You multiply 0 by anything, he's still 0. All right, so now let's look to the right and then to the left. All right, so I'm 1 above. If I multiply 1 by negative 3, we get 1, 2, 3, negative 3. If we multiply 2 by negative 3, we get negative 6. If we multiply negative 1 by negative 3, now we're positive 3. If we multiply negative 2 by negative 3, positive 6. My hand hit the board. Positive 6. So there we go. So notice it's just a reflection, but it's also been stretched. Get rid of that thing. My boo-boo is getting worse. Probably because I was holding the pen still. All right, so we're growing, we're stretched vertically. Right? And then we're reflected. So whatever was on the positive side before is now on the negative side. Whatever was on the negative side of the x-axis is now on the positive side. All right, so here is our base graph. Look how quickly that grows. Woo! All right, and so now we just need to, so this one here, by the way, was y equals negative 3 times the square root of x. All right, and now we just need to translate it. The 7 minus 7 under the radical, right? It's negative, and it's added, subtracted to x. Right? So it's horizontal, and it is to the right. There's an S missing here. Translated 7 units right. Okay, we have a negative. If we have x minus something, it's to the right. X plus something is to the left. The negative 4 at the end there is is 4 units down. Whoops, I got to switch those because the sentence doesn't make any sense. That's the only reason why. All right, we get to the, all right, so it's the 7 units to the right because to the down doesn't make much sense, and 4 units down. It's still missing an S. There we go, that's a better sentence. All right, so now we just have to count. If you can count 7 and 4, you got the rest of this graph. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. There's our first point moved. And then we only got 5 to move. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Boop, 2 done. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. And I missed this one. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. We've moved 4. Look at the 3 in the row there. Right? So notice now they're not, they're not diagonal 1 apart there. Now they're diagonal 3 apart. Right? A slope of 3 on that line there. Right? Because we're stretched 3 times as much. And then we're going to run out of space. Because 1, 2, 3, 4, 5. Let's keep graphing though. So our graph looks a little more normal. 6, 7. It's not that far off. 1, 2, 3, 4, right there. All right, so we'll just approximate the last point, give our graph a better shape. And here's our graph. Whee! There we go. There's our graph. All right, so the green graph there, that one is our graph, which is f of x equals -3 times the cube root of x minus 7 minus 4. And we're done. This is a cube root. Domain is all real numbers. And so is the range. Makes it nice. Got the arrows at both ends, right? You don't have a starting point. You have arrows, right? So it's going in all directions. Just like our cubic function is a domain range of all real numbers. So is a cube root. It's inverse. Right, so here we have it written in with a rational exponent. Right? But we learned in that nth roots lesson that an exponent of 1/3, that's just the same thing as a cube root. Right? So we have f of x equals the cube root of x plus 3 minus 2. Parent graph is y equals the cube root of x. Let's graph that. Oops, well, I dropped my pen. So I'll use my finger. Actually, my finger's doing a better job. 3, 4, 5, 6, 7, 8, 1, 2. Maybe I should use my finger for all my graphs. And then 2, 3, 4, 5, 6, 7, 8. All right, so here's my graph. Oh, my finger did such a nice job. You're hired, finger. We're going to translate we were just going to have two graphs here. The base graph, which was y equals the cube root of x. Right? And since I'd like to write in something other than black, I'm going to pick the pen off the floor and switch colors. We're going to translate our parent graph. I'm going to do the vertical first because to the up and down makes no sense. So x plus 3 is, minus 2 to the whole function means we're going 2 units down. We're going to do the vertical first. And blank units to the x plus 3 is 3 units to the left. All right, so we're just going to count 3 to the left and 2 down. We'll start with this one. 1, 2, 3, 1, 2, right there in the middle of my y, or in my middle of the equation there. 1, 2, 3, 1, 2. 1. And actually, we had no dilation, so guess what? This is what it's going to look like. Bump. There are the 3 in a row, right? The 3 of them just shifted. 3 to the left and 2 down, all together. 1, 2, 3, 1, 2. Right? The only time they're going to look anything different is if there's a vertical stretch, and then they'll just the line, like the line that connects those 3. It's not a line, it's a curve. They're just if you just looked at those 3 points though, they're kind of standing in a line, right? But that's actually curved. Notice I didn't go straight through there. There's no corners in the cube root function. But if we had a dilation, then they would just be separated, but those 3 are still being that little line there. All right, so domain, it's cube root. So it's got arrows at both ends. It's going to keep on going vertically and horizontally. There's our domain and range. And why does this one look like a fish? I guess it's still going to look like a fish. I tried to fix it, but it didn't change. All right, it looks fine. All right, let's do the next one. I think I've got 2 more. Right, here's our next one. All right, so we have g of x equals 1/2 times the cube root of x plus 5. Step 1, graph your parent function. One more cube root. Got to have this one memorized. I'm not even mentioning the points anymore. 2, 3, 4, 5, 6, 7, 8, except I like to count for some reason. And 2, 3, 4, 5, 6, 7, 8. Maybe because my graph has no numbers on it. This is a scale of 1, by the way, if you hadn't figured it out. All right, so there is y equals the cube root of x. Bam, that one's done. All right, so we have a vertical compression and a reflection. All right, so I'll write in green. Vertical compression, actually I'll write in red, I'll match the words. Vertical compression and reflection over it's going to reflect over the x-axis because it's in front. It's not under the radical. All right, so we're going to multiply our y values by -1/2. All right, this one won't change. All right, the positives are now going to be on the negative side. They're going to be reflected over the x-axis, and they're half as much. So we got a half here, -1/2, and we got -1. Same thing, but now we're on the positive side, +1/2 and +1. All right, so our graph has been vertically compressed and reflected. The red graph I just drew is y equals -1/2. What the heck happened to my 2? Let's fix that. Y equals -1/2 cube root of x. Right? And then we have to translate our graph. Right? Something's just added to the whole function. It's going to be 5 units up. So just move the whole graph up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 right there. Of course, this one's going to be right here, and this one's going to be right here, right? So they can keep their little pattern going. And 1, 2, 3, 4, 5 right there. So now here's our skinny little cube root function. He's all smooshy together. But this one is g of x equals, come on, -1/2 square root of x plus 5. And it's a cube root. All real numbers. We're done. Look how fast we're going through them now. We're zipping. I think I want only 2 more to go.